So a new version of the Segment Anything model extension for QuPath was recently released, version 0.3. And there's been a lot of quality of life improvements as well as functionality added in this update, which I wanted to do a quick review on. I'll post a link to the forum post, the GitHub repositories for the extension, as well as the Segment Anything model API server in the description of this video. But before I start, I want to preface that all the heavy lifting has been done by Ko Sugawara in collaboration with Pete Bankhead, and I don't aim to take any credit for the tremendous work that went into developing this extension. So, for those of you who don't know, Meta, not Facebook anymore, Segment Anything model was initially a segmentation tool trained on a very, very broad and robust data set consisting of, virtually any picture that contains binary masks, whether it be cats, dogs, cars, cups, pictures of literally anything. Because of the broadness of the training data used in such models, there was some interest in using it in digital pathology as an annotating tool. When you want to train your own nucleus segmentation algorithm or vessel segmentation algorithm, more often than not, you'd have to sit down and manually label these points using whatever tools were available at your disposal. In QuPath, that can include things like the rectangle annotation tool, ellipse, or even the wand and brush tools, but they're never really perfect. It might miss some fragments of the structure you want to segment or have trouble snapping directly onto the edges. And this greatly increases the time spent per single annotation, which means per unit time overall, you'll get less annotations for your training data. The intent of this extension is to be another option for annotating your data, and I'm going to quickly review some of the functionality here. So there's a nice little UI that showcases most of the new features. One is the ability to directly choose the model of choice, including the mobile version, which is the lightest weight and least computationally intensive. You can also have either rectangular or point-based prompts. So I'll quickly switch on the rectangle annotation tool and draw it over a few nuclei. And you can see it does a pretty reasonable job. Quite fast. And overall does a good job of snapping to the edges. And what happens if I use a heavier model? I'll do large for the sake of not spending too much time on this video. It takes a reasonable amount longer. And the reason it takes longer is because this is a CPU accelerated version. Even though I have a powerful GPU installed, I'm only using the CPU as most people who are probably watching this video or trying to replicate this don't necessarily have a CUDA-capable GPU inside of their computer. They might just have one with a beefy CPU, or even a laptop, for example, with integrated graphics. So I want to show, realistic applications of this. So you can see it does take a little bit longer. Not necessarily any better, but in specific use case scenarios where you really want to get a good segmentation and you don't have to spend the time of running SAM over and over again, that might be a situation where you'd want to use a more computationally intensive model. Now, in addition to rectangle prompts, we can also do point prompts. So simply drop a point here, and it'll attempt to segment it. Now this is because I have lab mode turned on. If I turn that off, we can start putting multiple points down if we wanted to, say, segment the entirety of this vessel's lumen. So we'd put a few prompts here. I don't believe we really need that many. And click Run for selected. Excellent. There is the option to include background prompts. However, I haven't really got that to work. And I'll show you an example of how I thought it was supposed to be used. So let's say I only want to take the endothelium of this blood vessel. Let's use this one as an example. But I didn't want to include the lumen. Well, I was under the impression that first you would have foreground checked, and then you would put a few points down for the foreground. And draw points, but this time we do background. Except that it's not necessarily being a different class, so I have no idea how SAM API can differentiate the two. I'll click run for selected, but I have a feeling it's just going to take, this whole structure, so it's not excluding the points I want it to be excluded. I don't believe there is any documentation. Also here, as you can see when I'm switching between foreground and background, there is the ignore class. What if we manually insert this ignore class? We'll delete all objects. Put some background prompts. Now it's showing up as ignore. Interesting. Now, let's put some foreground prompts. I think it might still be putting it as ignore. Yeah. So in that case, perhaps I have to click add. Yeah, let's give that a shot. So it's kind of hard to see, but we've put point exclusion prompts inside the lumen of the blood vessel as well as outside, and only put inclusion prompts on the endothelium of the blood vessel. If we click run for selected, still doesn't do as good of a job as I initially expected. It also appears to not have deleted the ignore prompts. So you can do with that information what you will, but personally I haven't really found a lot of ways I can use this sort of background foreground switching, at least without any issues. We also have the ability to choose mask generation, so either a single mask, or we can have multi-mask all, meaning it'll generate both the largest mask available, the smallest mask available, and the best quality mask available, or multi-mask individual ones, so just the largest, just the smallest, and just the best quality one. Of course, I believe it's going to be more computationally intensive if it takes the best quality one under multiple masks, because it still has to create all three of them. But again, with GPU accelerated segmentation, that shouldn't be an issue. So we just demonstrated that this is a CPU intensive process because we have our SAM API server built with, or rather built without CUDA, as evident by this little warning message. If we deactivate the environment, well, first we have to stop the server. Deactivate the environment. Reactivate the environment that contains CUDA support. And just have to start up the server again. Now we can start taking a look at some of the more computationally intensive model predictions. There we go. So now, if I switch over to something like VidH huge, multi-mask best quality, and we draw around this vessel, quite bizarre that it generated all these annotations. I don't know what to make of this. Let's try that again. Rectangle tool, generate a square. Could be a bug. I have no idea why that happened. But yeah, it is quite promising as an annotation tool. What I haven't shown yet, and I kind of regret not showing it before I started up this other server, was the auto mask. The auto mask will basically attempt to generate masks for each of the objects in your field of view. So for example, if I were to run this right now, it would try and segment whatever objects that it sees in this image. And in previous times I've tried this out, it happened to be the empty space of these adipocytes, and it did a really good job. If, however, I click run now, nothing happens. There currently is a bug where it states that could not run torch vision : NMS with arguments from the CUDA backend. Torch vision definitely has CUDA support. I just think there's some issue with the argument being passed to the SAM API server. And hopefully in a future release, I'll demonstrate this. But yeah, it's less useful because of all the different parameters that you have to adjust, and you still have to perform quality control on each of the different annotations that are generated. Which is why, for the sake of this video and in the interest of time, I won't be discussing this too much until the GPU support issue is resolved. So going back to the main SAM tool, let's take a look at some other use case scenarios. I can actually see that from a previous run. I did a good job at segmenting all these different tissue fragments. We've got live mode turned on, rectangular annotation tool selected, and we draw a few rectangles. I believe if we try and include two, yeah, it'll only go for one, so one object per prompt. And this is a great way of quickly being able to generate tissue level annotations without having to train a pixel classifier or play around with a pixel thresholder for differentiating background from foreground objects. Let's find another example. Segmenting erythrocytes. Can we identify this erythrocyte-filled lumen of the blood vessel? Yep. Can we detect all of these small little fat droplets? Seems like it. And even if you have parts of your area that exceed the bounding box, it is able to find those fragments and segment them accordingly. Well, to an extent. Now, in comparison, let's say I use something like the brush tool in QuPath to identify these objects. We have to fill it in, but it's not really snapping to anything. So I mean, if we were to train a pixel classifier from this, it might get confused by these little edge cases. The wand tool does help considerably with this, because I believe it uses some contrast-based algorithm for edge detection. But for very thin slivers, you'd have to zoom in quite a lot for it not to accidentally paint over those areas. So you can see the moment I started working my way to it, it kind of spills over. It's a lot less computationally intensive, but again, if you've got a powerful GPU, you might as well go with the better annotating tool, which is the segment annotating model, as opposed to using the wand tool. What's also important to note is this only segments structures in your current field of view. Even if I zoom out and I wanted to segment, say, the whole image, which it does a great job, but as you can see, it was almost instantaneous. It's not using the raw pixel values, it's using the rendered pixel values of what's being shown in the viewer itself. This is especially important when you're working with multiplexed images because they can have, quite a lot of channels present. Let's say I wanted to segment these circular structures. Sure, I can put a square around it. Does a good job of segmenting it. But if I start turning on all the channels present in our multiplexed image, you can start to see this kind of becomes just a huge white mess. Because you're trying to blend in many, many different colors far beyond what the human eye is capable of resolving. Now, if I were to try and draw an annotation around the structure, which I honestly have no idea where it is anymore, I don't expect it to really do anything. Yeah, it basically snaps more or less to the bounding box of the drawn annotation, and with a much lower quality as well. So when you're using the segment anything model, make sure you set up your image in the viewer in a way that you yourself can see the structures you want to segment. Because if you can't see them, chances are Sam is not going to be able to either. It also supports non-standard imaging modalities as well, such as imaging mass cytometry, which has floating point precision 32-bit data. So it's not very common that you see machine learning models that can be applied to things other than 8-bit or 16-bit integer-based images. In this case, let's see if we can segment arteries. Does a great job of segmenting arteries. No issues there. What about tubules? Yep. Yeah, does a great job. I don't think I have any glomeruli in this image, but I assume with the relevant structural markers, it'll do a reasonable job of segmentation as well. But let's give it something a little bit more tricky. How do we segment interstitium? In other words, everything other than tubules and arteries, that empty space. Well, this relates back to the point annotations, which I've yet to work, but we can turn off live mode, put on a few annotations. Let's see if I turn on live mode. So foreground points first. This is what we want to keep. We turn on background. No. Perhaps it has to be in non-live mode. So give a few foreground points. Give a few background points. Run for selected. No foreground objects for use in detection. There we go. So now you can see it does a much better job. So I don't believe this is specified explicitly in the documentation, but in order for you to differentiate between foreground and background prompts, the foreground prompts must be unclassified and the background prompts must be ignore with a little bit of an asterisk above it. Yeah, I don't really see any mention of it here. Let's see if we can... So it is actually mentioned. Points with ignore classification or pass the model as background prompts. Cool. So let's find one additional example. Let's give it something a little bit more tricky. Can we segment this very, very thin wall of smooth muscle actin positive parasites and exclude both the lumen of the blood vessel as well as the surrounding tumor? We will make sure live mode is turned off. Foreground prompts will begin putting down. And background prompts. I have a feeling this auto set thing might be breaking things, so I'm just going to uncheck it. Put some background prompts inside the lumen of the blood vessel. Yeah, so it turns out the foreground prompts must be unclassified to work. Now if we run for selected, and, let me just position this to be nice and dead center into the field of view. Run. So close. I mean, it didn't exclude the lumen as we initially wanted to with our ignore prompts, but it did exclude the areas outside of the blood vessel. So this just goes to show, you'll never have a perfect annotation tool. It's really contingent upon the ability to really delineate those structures you want segmented, in this case, the blood vessels themselves, but also ensuring that you have proper functionality from all of the tools you want included in your tool set. Even though I included the lumen of the blood vessel as negative prompts, it didn't really seem to care about that, and instead classified the whole object instead of a donut-shaped ring, which is what I initially expected. You can have semi-hybrid methods of segmenting objects, like using pixel single measurement threshold, or what's it called? Thresholders in QuPath followed by manual annotation cleanup. But I believe SAM has situated itself quite nicely in the field of annotating tools, something that hasn't really changed over the past decade. I mean, for the longest time, you've had rectangular, circular, line-based annotation tools in not only Fiji and ImageJ, but Apereo ScanScope. You also had things like polygon annotation tools. One of the new features I liked most about QuPath was the wand tool, which kind of attempts to do a little bit of like edge detection. So it's kind of detecting the edge of the blood vessel, but it's not perfect. If we look at these CD31 positive blood vessels, again, we can also segment it this way. But generally, I'm sure Sam would probably do a much better job of segmenting these blood vessels given a rectangular prompt. So if we do live mode, give it a little rectangular prompt, I would say that's a smoother blood vessel. On that note, I believe I've covered the extent of the functionality I want to showcase. If you have any questions, comments, or concerns, well, the people to actually ask would be Kosu Gawara and Pete Bankhead, the main developers of this current revision of the SAM extension. And you can post those questions down in the, well, probably in this thread, or any future requests you might want to have as well. In any sense, thank you for taking the time to watch this video.